So let us now talk about the effect size. I have tried my best to find an online calculator that would help you calculate the effect size, because this is something that you will do yourself. So this is not something that you are going to get a table about. You have to calculate the effect size yourself. And the easiest one that I have found out is at this website. So I'm going to go to this website. And this is what this website is. So if you look at it, it actually calculates the effect size for for independent t-test, paired t-test, Mann-Whitney test, Wilcox test, one-way ANOVA. So we want to look at one-way ANOVA. So I'm going to click on this one. So here is my test. I'm going to put in Viagra dose ANOVA. The reason it popped up is because I had already tried it once. So it is an independent group because they are not the same people. It is a parametric. So parametric statistics is when your assumptions are met, which is why we do one-way ANOVA. Non-parametric is the Mann-Whitney test when my assumptions are not met. This is really important for you guys to remember. And so here what I will do is I am going to copy paste my group 1. So I'm going to copy paste my group 1. I am going to copy paste the group 2. It doesn't matter which one goes where. I am going to copy paste the group 3. Those are my 3 samples, right? So here I had already put there were 3 samples. So that is why only 3 of these boxes opened up. If I have more samples, then I can always do 4 and 5. So then I press submit. And as soon as you press submit, you are going to see that it gives you a lot of good statistics. So you really don't even need SPSS to do this. This is really great statistics that you have over here. So you look that sample 1, which was my placebo, 2 was my low dose, and 3 was my high dose. 5 each, mean, standard deviation, standard error, median. It tells you it is one way. It even gives you the Levine's test for homogeneity of variances. And it gives you the ANOVA test statistics. It gives you the significance. That is what we also got. We got 0.025. So it tells you, and it even gives you a conclusion that based on the significance level, there is statistical difference between these samples. Now, it doesn't tell you where, like it's not doing a postdoc or anything for you, but at least it's giving you the statistical. So this is really good data over here. And then you have between groups, within groups. Here's your degrees of freedom. This is your sum of squares and mean squares. What you are concerned with is this. This omega is your effect size. You get 0.354. That is your effect size. And that is all you need from this whole thing. But you can always look at this data, this is so interesting. So let us go back, and this is where this table is. You just need this value. And this is the value that you use. Now, if you want to do it, if you are a math person, or even if you're not a math person and you actually want to do it, just do the calculation. I give you the formula here, which is SS contrast minus parentheses DF contrast times MS within, and then divided by this. So where are these values coming from? These values are coming from this table. Sum of squares is the SS contrast, which is this value. Then you have your mean square and degrees of freedom. So if you look at this one, this is where it is coming. The degrees of freedom was 1. That was 1.97 divided by SS total and mean. So SS total is what? Here is the SS total. That is what I have. And then I am looking at MS. This is within group 1s. And I have MS within again. So 1.95. And that gives me this value. So you can report any of these results. Both would be correct. But the website is easy. You just have to enter the data, copy paste the data, and that is all you needed to do. Okay, so this is what the effect size is. If you have any questions, please ask me, but the effect size will be there when you report on the one-way ANOVA.